All right, this lesson starts chapter 9, which is going to be significance tests for proportions. Today's really just an introduction to significance tests. Our learning targets are to state appropriate hypotheses for a significance test about a population parameter, interpret a p-value in context, and make an appropriate conclusion for a significance test. And it is everybody's favorite lesson. Is Miss George good at free throw shooting? Of course the answer is yes, but let's just see how good I am. So, Miss George claims she is an 80% free throw shooter. To prove her skills, she shoots 50 free throws and makes 32 shots. Is Miss George exaggerating about her free throw skills? Pause the video. I'd like you to work through this as much as you can. There are some things that maybe you won't know, so skip those, but fill in as much as you know, because at this point you should be able to answer quite a few of these questions. So, make sure you've paused the video. Let's go over them together. So 1, identify the population, parameter, sample, and statistic. Remember that a population and parameter go together, sample and statistic. When we learned this at first, P and P go together, S and S. So our population is going to be all free throws by me, by Miss George. And the parameter of all of the 3 free throws is going to be the true proportion of made free throws. Now, the sample is the 50 free throws. I'm just going to do FT that I shot. And P hat, coming from, again, our sample, P hat is 32 made shots out of 50 for a sample proportion of 0.64. Clearly, I was having just a little bit of a bad day. All right, now there's 2 possible explanations for why I only made 32 out of 50 shots. And this is just 2 things that could be true. The first thing that could be true is that I am an 80% free throw shooter, but had a bad day. So I just wasn't shooting as well on this particular day. Or option number 2, which probably is not the correct option, but you know, who knows, is that I am a liar. I mean, I guess exaggerating. I'm not lying. So, to test Miss George's claim, we will assume number 1, she is an 80% free throw shooter, and examine the likelihood that she makes 32 out of 50 shots through simulation. Right here, this is a really important piece. Like, I know it seems like such a little part of the lesson, but this is explaining what we do and how we do it. We are going to first assume that she is an 80% free throw shooter. We are going to assume that P is 0.80. We're going to assume that my claim is true. Then we're going to examine the likelihood of getting my sample statistic, P hat, if the claim is true. So what we're setting up here, this claim is now what we call a null hypothesis. So we have a null hypothesis, which is that I am an 80% free throw shooter, which is really possibility number 1 back here in number 2. So number 1 represents our null hypothesis. And really it just represents that the hypothesis that whatever is being claimed is true. Very straightforward. Whatever reason it is that our statistic doesn't exactly line up with it, the claim is true. But then there's a second option. There's a second explanation. That is that it's not true, that I'm a liar. That is what we call the alternative hypothesis. So for us, and we're going to do HA, it's not going to be P is not equal to 80. We're going to look at our statistic, right? It looks like here I am a less than 80% free throw shooter. So we're going to say our alternative hypothesis is that P is actually less than 80. Now, I did not provide you a spinner, so as you got to this section, maybe you were able to find a way through random sampling or an online spinner in order to simulate 50 spins and making 80% of them. What you're trying to do, if you're going to make your own spinner, to represent 80%, let's think, that is 4 out of 5. So you could just make a 5-section spinner. 1, 2, 3, 4, 5. And we're just going to say that one of them is a make, or one of them is a miss, and the rest are makes. So that's how you would simulate this, and then you'd spin 50 times. Since we don't have the whole class here for data, I can't do 3 through 4 exactly, but number 5, I'm going to give you the class data from last year. So let's plot these points. Notice as we are plotting these that this is a good dot plot because this dot plot is labeled. It has equal intervals and it has, I guess those are the two things. Label and equal intervals, that it is scaled properly. Sometimes we forget that we really need to scale it in a consistent form in order for our dot plot to convey the data in a correct manner. All right. Now, what does each dot represent? If you had gotten a little bit stumped on 3 to 4, take a pause now that you have the data, see if you can fill out the rest. All right, so now, what does each dot represent on this dot plot? It is the proportion, right? Remember, be very specific. It's the proportion of free throws made from a sample of 50 free throws, specifically by an 80% shooter. And this is really important, okay? Again, we are collecting data. We are simulating based on the claim being true. So this simulation is simulating that the claim is true. I've underlined too much. So I'm assuming that it is an 80% free throw shooter. All right. One student says each dot represents the proportion of free throws made out of 50 free throw shots by Miss George. Is this correct? Now we just went over what each dot represents, but just to reiterate, no, this is not true because we don't know. We do not know for sure that Miss George is an 80% free throw shooter. The dots represent an 80% shooter. So be very careful. Don't say that it represents my shots or whatever your context is because you don't know that yet. Number 8, what percentage of the dots represent a percentage of 64% or less? Wow, that's a lot of that word percent. All right, so 64%, we have one dot right here. So we're going to block it off from that dot or less. We have only one dot out of the 50 samples total. So what percentage? 1 out of 50. That is 2%. So interpreting this percentage in context, I'm going to start with maybe what you wrote, and then I'm going to add to it. So leave some space. There is a 2% probability that Miss George makes 32 out of 50 or less free throws. So hopefully you were able to at least get this much, or something that seems like this, right? At this point in our class, you should be able to see that percentage and interpret it, at least to say that that's the probability of making this or less. Okay, this is something really important. If you're not quite understanding dot plots and data, you need to come ask some questions. But I want to add some more to make this interpretation even better. So first off, it's not just a 2% probability that I make 32 out of 50 shots or less. Because remember, as we said in question 7, these dots don't necessarily represent my shots. They would if we assume that I am an 80% shooter. So assuming Miss George is an 80% shooter, there is a 2% probability that Miss George makes 32 out of 50 or less free throws purely by chance. So we add that in there, purely by chance, because this is less than what you would expect. So this is the probability that I were to get such terrible results purely by chance. And if it's a really small probability of it happening purely by chance, remember we've talked about this, if it's really unlikely that it happened by chance, what's more likely is that I am lying, or that the claim is not true. So for your conclusion here, hopefully you wrote some conclusion, because we know this part. We can do this concluding. That 2%, I'm going to compare it to our cutoff of 5%. Because it's less than 5%, we do have convincing evidence, and that's what I'm going to write. We have convincing evidence that Miss George is lying. Ooh, look at that. I'm going to spell lying wrong. Is lying because 2% is less than 5%, meaning it is unlikely that an 80% shooter performs that poorly. Now, I know what you're thinking. Ha ha, we proved you wrong. That's not true. I will see you on the basketball court on Monday to prove myself. I am an 80% free throw shooter. Anyway, what we wrote here in number 9, this is our conclusion. We always are going to continue with our state plan do conclude. Here we go. We have a conclusion. We're going to go into a lot more of that as we continue on this unit. Today was really just an introduction to significance testings. The main things that I want you to walk away with, because we don't have important ideas today, is that we have these two new things, which is a null hypothesis, HO, and the alternative hypothesis, HA. The null hypothesis, HO, that is always assuming the claim we are given is true. The alternative hypothesis is assuming that the claim is not true, and typically it is towards the direction of your sample statistic, because I had a p hat that was less than the claim. I thought that for the alternative hypothesis, p should be less than the claim. From there, we collect our data, assuming that the claim is true. So all of these dots represent an 80% free throw shooter. We compare that to the results that I actually got and count how many dots were at or below my results. We chose at or below specifically because we said that we thought P would be less than 80. So if we are less than 64, that is going to be what we want, right? We want to be less than 80. Then from here, we were able to find that percentage and to interpret that percentage, and therefore finally make a conclusion that we would have convincing evidence against the null hypothesis, against the claim. All right, guys, I hope this was a good little introduction to significance testing. We will move on Monday to continue learning about these types of tests with proportions. See you then.